Hello everyone, my name is Shyam Manawat and I welcome all of you to the series of Basics of Algebra. In today's lecture, we are going to discuss some formulas, some basic formulas which you are already aware about. So it will be kind of a revision for you, and then we will see what more do we understand from those formulas. So let's get started. So first set of formulas are bracket square. So I am sure you are aware about a plus b square, which is a square plus 2ab plus b square. I have seen some students writing it like, they write it like a plus b whole square as a square plus b square plus 2ab. Like if you arrange a square plus 2ab plus b square, instead of that if you write a square plus b square plus 2ab, it's not wrong. But I do not advise this. Why? I will tell you later in this same video. So remember this formula like a square plus 2ab plus b square. Similarly, we have formula a minus b whole square, that is a square minus 2ab plus b square. You have minus here, so this term is changing the sign. Instead of plus, here you have minus. A square and b square both are positive. A plus b plus c whole square, yes, this you can remember like a square plus b square plus c square. Then you take two terms at a time. So 2ab, 2bc, 2ca, 2ca instead of ac, let's write it ca. I know it's one of the same thing, but you know there is something called a cyclic approach, where we see B after A, C after B, and then A after C. So let's try to remember like AB, BC and CA. Okay, great. Now if you have cube terms, bracket cube. So what is the expansion? A is a cube plus 3a square b plus 3ab square plus b cube. And this is for minus sign. If you rearrange it here, if you take a plus b square, like here, if you rearrange this, you have this a cube and b cube together. You have a cube plus b cube at one side and remaining 3a square b and 3ab square. If you shift to the other side, what do you get? You get a plus b whole cube, which was already there, minus 3a square b minus 3ab square. Now here if you take minus 3, because in both terms you have 3, okay, if you take 3 from both terms and a, which is again there in both terms, again b, which is there in the both terms, so remaining will be what? A plus b, isn't it? Yeah. So you can write a cube plus b cube as a plus b whole cube minus 3ab into a plus b. I want you to write these formulas. You should write these formulas, okay? I know I told you that I don't like many formulas, but this is necessary. Yeah. So write this down. So if you rearrange it, you can also say this. I have shown you how did we get it. More than how did we get it, we can focus on what is the final outcome. Okay. Great. So bracket square, bracket cube. Now we have, so I call this bracket square, bracket cube, and then we expand this, we open the bracket. I call these formula as expansion formulas. Okay, expansion formulas, which we are going to discuss here again. So stay tuned, don't skip any part of this video. Terms, square terms. So you have a square minus b square, very famous, very commonly used. I am sure you must have used it many times in your school also. So a square minus b square, a minus b into a plus b, a minus b into a plus b. Yes, many people write it like a plus b into a minus b. I know the outcome is same, but I still advise you to write it a minus b into a plus b. I will tell you the reason for this later in the factorization section of this particular video. So I will discuss this in detail. If you have got cube terms, so a cube plus b cube, we have got a plus b, and then a square minus ab plus b square. A cube minus b cube, a minus b we take first, and then a square plus ab plus b cube, b square. Yeah, so a square plus ab plus b square. Yes, so these formulas you should remember, you should by heart, it should be on your tip of tongue. Necessary, that's why I'm telling you to remember this. Okay, now let's discuss more in detail about these formulas. So I told you that this a plus b whole square, this type of open bracket, bracket of the power of the bracket. If you open this, what you get is a square plus 2ab plus b square. Okay, so I call this as expansion formula. So a plus b whole cube, what did we get? We got this as a cube plus 3a square b plus 3ab square plus b cube, right? So expansion formulas. Now let's try to generalize and understand the similarities between the bracket square and bracket cube. Pay attention. Now for the time being, if I remove the coefficients, what is coefficient? We have discussed this in the previous lecture. What is coefficient? Yes, the number with the variable. So here if I remove the numbers from here, do you see that ab square, only ab, if you look at only ab, you got a square plus ab plus b square. Yeah, look at this. If you have power square, so each term power is 2 square. A square, now a to the power 1 in the second term, a to the power 1, b to the power 1. What is 1 plus 1? 2, right? So the total order of this particular term is 2. Do you remember order? We have discussed in the previous lecture. And this is b square, 2. So each term has order 2 if the bracket power is 2. Same if you see in the next expansion, a plus b whole cube, that starts with a cube, the power is 3, a square b to the power 1, so 2 plus 1, again 3, and then here a b square, 1 plus 2, again 3, and then b cube. Yeah, yes. So in that case, so what do we have? We have ab, or let me write this like a plus b whole cube. Pay attention here, pay attention, don't skip, pay attention. This is a cube plus, okay, let me write it like a cube b to the power 0. Yeah, any term power 0, any term power 0 is 1. Okay, this we will discuss it when I am going to discuss indices. Okay, so I'm going to prepare a separate video on the power. Okay, so here this indices, so we are going to discuss there. Well, coming back to this concept as of now, so remember any term power 0 is equal to 1. So here we don't have b, so b to the power what? 0. Do you see 3 plus 0? 3. Yeah. Then if you see here, the power of a is reducing by 1. Instead of 3, it becomes 2, and power of b increases by 1. So instead of 0, it will become 1. Then you have a, what was a to the power? 2, now it is 1, reduce, and power of b increased. Power of a reduced, power of b increased. Right? As of now, we are not talking about the numbers we had. What numbers we had? We had a square plus 2ab plus b square, a cube plus 3a square b plus 3ab square plus b cube. So I will talk about those numbers also. But first understand what is the change in behavior of this a and b, right? Okay. Now if I tell you to write a plus b to the power 4, pause this video, try writing this. Only in terms of a and b. We will discuss the number, what should be the number there. We'll discuss that later. But first try writing in terms of a and b. What will you get? Yes, I am sure most of you must have got the right answer. So here it will start with a to the power 4. Yeah, whatever is the power of bracket, will start with that. B is 0 here. Now a reduced by 1, so a become a cube. B increased by 1, so b was 0 in the previous term, it will become 1. 3 plus 1, 4, so total power is still 4, right? Reduce power of a by 1, so it become a square. Increase power of b by 1, b square. Yeah, reduce power of a to the power 1. Increase power of b, a cube. Yeah, so we never write power 1, right? So it will be a into b cube. Increase power of b, reduce power of a, so a will become power 0. So a is wiped out, right? You must have got the same arrangement. Yeah, same expression here. A to the power 4, a cube b1. We never write 1, so a cube b, a square b square, ab cube, b to the power 4, right? Okay, let's try for a plus b to the power 5. Pause the video, try writing it by yourself first. What do you get? A to the power 5 plus a4b, yeah, reduce a by 1, so a cube, b increased by 1, b square, a power reduced by 1, a square, b power increased by 1, b cube, a power reduced by 1, a, b power increased by 1, a to the b to the power 4, a power increased by 1, a becomes 0, a to the power becomes 0, and b increased by 1, b to the power increased by 1, it will become 5. Yeah. Yes. How is it looking? Brilliant, no? Yeah. At least a and b we are able to arrange. Now let's talk about the numbers. Are you okay with this? Are you okay with this? Yes? Okay. Now let's talk about the numbers which we have. So this expansion I will start from, let me start this from a plus b to the power 1, which will be nothing but a plus b itself, right? Power 1 will not make any difference, correct? Okay. Now let's talk about the numbers. Now when you see a plus b to the power 1 here, the number we had in case of power 1, we had a plus b. So now if you look at the coefficient, the numbers, the coefficient of a and b there, that is 1 and 1. There is no number in the multiplication, so we can always take 1, right? Okay. Now when you see a plus b whole square, if you remember, a square plus b square, a square plus 2ab plus b square. Do you remember that? Do you remember that? A square plus 2ab plus b square. So what is the coefficient of a square here? Nothing. So it has 1. AB, for AB you got 2 and for b square you got 1, right? Let me write it here. Let me write this here. One and 1. Here we got 1, 2, 1, and then see it will become a beautiful triangle, the pyramid shape. Yeah, the triangle shape. Now if you remember a plus b cube we had here b cube, so no coefficient, so we can take 1, plus 3a square b, so number was 3, plus 3ab square, so the number was 3, plus b cube, so the number was 1. You want to see that? A cube, the coefficient is 1, there is nothing, so it is 1. 3ab square, so just look at the number 3, just look at the number next 3. What is the coefficient of b cube? 1. Yes. So do you agree with me here? Numbers with a and b, the coefficients of a and b, right, of each term. Now if you see the relation there, here it is always starting with it's always starting with 1 and ending with 1. 1, 1, 1, 1. So if I want to write for a plus b to the power 4, this should also be 1 and end with what? 1, right? Now if you look at these numbers, so this is nothing but 1 plus 1, that is 2. Did you understand? This is 1 plus 1, 2. Yeah. Now look at this. This is starting with 1. 1 plus 2 is 3. 2 plus 1 is 3 and then again 1. Are you finding the relation? So here the next number here should be 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. So these should be numbers, the coefficients, when you write what? A plus b to the power 4. Yeah. So if I want to complete these expansions now, I can say the numbers. I can say the numbers, the coefficients here are, for a plus b, we got 1, 2, 1. So coefficient 1 we never write, right? Multiplication of 1 will not make any difference. Power 1 will not make any difference. Divide by 1 will not make any difference, right? For cube, a cube plus 3a square b plus 3ab square plus b cube, right? Yeah. This I tried to explain in terms of a and b. Now power 4, what did we get for power 4? 1, 4, 6, 4, 1. So what do we have here? 1, we never write. 4, 6, 4 and then 1. So what is a plus b whole to the power 4? That is a to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the power 4. Yeah, I know you might be having a lot of questions in your mind, but stay tuned. I will try to cover all the questions, because I know it's been almost 12 to 15 years I'm teaching students. So I know what are the common questions they have. So I will cover that up. Just stay tuned. Now for power 5, I want you to find out what should be the coefficient here for a plus b to the power 5. You got what should be in terms of a and b. That's clear. Okay. Now let's see what are the numbers. So you can pause the video and then try completing this part. Right? What should be the numbers here? Yes, of course, it should start with 1, end with 1. What do we have? 1 plus 4, 5. What do we have? 4 plus 6, 10. What do we have? 6 plus 4, 10. What do we have? 4 plus 1, 5. So what are the numbers we got? 1, 5, 10, 10, 5, 1. Let's write them out. Let's write them here. 1, then we had 5, here we had 10, again we had 10, and then we had 5, and then we got 1, right? Okay, now for practice you can try for a plus b to the power 6. Alright, so this triangle which you got here, is called Pascal's triangle. Yeah, some Pascal fellow he found out that these are the similarities which we are talking about today. That if you keep on increasing the power, this triangle keep on going in this same series. Yeah, if you want to try for a plus b to the power 6, yeah, which I told you to try it by yourself, do the AB things, yeah, a to the power 6 and then go on. Let's see the numbers. I'm sure you can do that also. Start with 1, end with 1 here. Now 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15 again, 5 plus 1 is what? 6. So here we got the numbers, the coefficient in case of a plus b to the power 6 expansion. Yeah? Okay, good. Now let's write the learning what we understood from this expansion. First, what are learnings? So for you can also make your own points. What did you learn? What did you find common in all this expansion? Common in all this expansion. You know, what did I find? That if you look at this, it is starting with a to the power of bracket and b to the power of bracket. So it's starting with a square and ending with b square in case of a plus b square. In case of a plus b cube, it's starting with a cube and ending with b cube. In case of a plus b to the power 4, starting with a to the power 4 and ending with b to the power 4. In case of a plus b to the power 5, starting with a to the power 5, ending with b to the power 5, right? And this we have got Pascal triangle, right? So now first thing we understood from here that if it is a plus b to the power n, we are trying to generalize, okay? Let me use a different color here. So a plus b to the power n, if you try to generalize, it always starts with a to the power n and end with b to the power n, right? Yes. What else? What else do you understand? The power of a keeps reducing and power of b keeps increasing. Yes. So next what we understood here is the power of a keeps reducing and the power of b keeps increasing, right? That is the second point. Do you agree with me? Yeah? Great. Okay. Then, so this is first point, this is second point. What else? I can also say all the terms are divisible by a except the last term, which is what? B to the power n, right? B to the power n. Do you agree with me? Do you agree with me? Yes, no? All the terms here are divisible by a. Yeah, see, if you divide the first term by a, it will be divisible. If you can cancel that, right? If you divide second term by a, you can cancel. If you can divide third term by a, you can cancel. Only the last term will not, because last term does not have a, so it will not be cancelled, right? So this is what I am trying to generalize. So do you agree with me? Do you agree with me? Oh God, I by mistakenly removed a also from you. Okay. Did you understand? Do you agree with me? Any expansion you see this, they all have a except the last term. So all these terms will be divisible by a easily. You will get integer number, right? Except the last term. I am going to use these properties later. So please remember these properties. That's very important. So the fourth point here, The fourth point here. Note these points. They are all important. Note these points. Generalized. They all are important. What is that? All terms are divisible by A except the last term. And same we can see, all terms are divisible by B except the first term. Don't you think so? All the terms are divisible by B except the first term. Do you agree with me? Because again the first term will have A to the power n, which will not be divisible by B. Rest all will have B. Yeah. Do you agree? Yes. All these terms are having B except the first term in any kind of expansion. Right? So we can say all terms are divisible by B except the first term. Correct. And that is A to the power n. Okay. Now, in the expansion, so we have tried all the positive terms like A plus B, A plus B, A plus B. What if we do A minus B? What if we do A minus B? What will change if I do A minus B? What will change if I do A minus B? Let's see. In case of A minus B to the power n, so A minus B square. Do you know what is A minus B square? Yes, we have covered in this video itself. A square minus 2AB plus B square. Do you remember, if I do A minus B whole cube, then what will happen? You have A cube minus 3A square B plus 3AB square minus B cube. Right? Now, if I take, okay, now let's say A minus B to the power 1 also. A minus B. So, if I try to generalize by looking at these three expansions, if I try to generalize, again, I am calling these formula like expansion formula. You may call it something else, but let's use a common term so that we can connect. Yeah. So, if you try to generalize, you will understand that this sign is alternate, like first term is positive, second term is negative. First term is positive, second term is negative, third term is again positive. First term is positive, second term is negative, then again you got positive, and then again you got negative. That's why I told you to write like A square minus 2AB plus B square. And I told you that, do you remember this, when I told you that write like A square plus 2AB plus B square and not like A square plus B square plus 2AB. Remember that? I told you do not write this as, the result is same, but if you do this, you won't be able to generalize. See, you won't be able to generalize and find something which is common and will be able to proceed further with next power. Yeah. So if you write it the way it is, it will be beneficial for us to generalize, right? Same way, if you got A minus B square, write it like A square minus 2AB plus B square. So you can understand that plus minus sign is alternative. Yeah, it is alternate. For alternate term you get plus, and for alternate term you get minus, right? So plus minus, that's happening. You can also see here, if you want to understand this way, you can also see here, for odd power of B, what is odd? Okay, what are odd numbers? 1, 3, 5, 7, so on, odd numbers, right? For every odd power of B, you have negative. B to the power 0, here you got B to the power 0, so there is no B, positive. B to the power 1, odd, you got negative sign. B square, even, you got positive sign. B to the power 1, negative, odd number, yeah, odd power of B, you got negative sign. B square, even number, you got positive sign. B cube, power of B is odd, you got negative sign. Yeah, so for every odd power here, you are getting negative sign. Okay, Rest everything is same as the previous expansion, the a plus b whole square or a plus b whole to the power n. Yeah. Rest everything is same. Pascal triangle will follow same, the coefficient 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That will follow the same pattern. The power of a and b, it will follow the same pattern. Power of a will keep reducing, power of b keep increasing. The only difference will come here is the negative and positive sign, because we got a minus b, a minus b, a minus b, right? Okay, so everything will be same, all these properties will be same, all these properties will be same for a minus b whole to the power n. Pascal triangle will be same, everything will be same. The only difference here, so because everything is same, I am not writing, I am not giving you all the examples, but because everything is same here, I will only add one more point. I will only add one more point here, which is that one more point, fifth point here, and this is negative sign. Yeah, that's why I told you, do not skip. Are you able to generalize? Are you able to understand the Pascal triangle? Pascal triangle, yes. Okay. Here you got. So you have the positive, or how do you want to write it? You can say every odd power of b term, okay, every term with odd power of b is negative here, okay. Or you can also say positive, negative is alternate. Yeah, whatever you want to learn, whatever you want to understand, but this is the expansion. Yeah, so are we able to generalize? Yes. Are you able to write these 5 points which are important, because I am going to use them when I am going to discuss remainder theorem in number system. Remainder theorem in number system. Here we have remainder theorem in number system. So here I am going to discuss. All right. So I know it's quite far, but still it's part of the syllabus. So I will give you reference of these properties. So it's very important to remember these properties. Yeah. Okay. Now let's talk about factorization. Very important, factorization. So we have formulas like a square minus b square, which is what? A minus b into a plus b. So you remember I told you that to write a minus b first, and now I am going to tell you the reason behind it. Then you got a cube minus b cube, that's also a minus b. Then you got a square plus ab plus b square, all positive. Yeah. Now if you try to generalize this factorization, why are we calling this factorization? Because you know the way we have 6, what are the factors of 6? 2 into 3. If I factorize 6, I have 2 and 3. Yeah, so something which you multiply and get the same value again, multiply and get the same value again. This is multiply and you get the same value, a square minus b square. Yeah. So these are the formulas. Okay. Generalize. Do you see the first factor, first bracket, I can call it first bracket, or first factor is always a minus b in case of a to the power something and b to the power something. The power should be same. If I say a to the power 4 minus b to the power 4, here again I should have a minus b as one of the factor. And the second factor is what? Now pay attention here. The second factor is what? If it is a square term, the second factor is power 1, each power 1. If it is cube, the second factor is power 2. See, a square, 1 plus 1, 2 again, and then b square. Yeah? Are you getting it? In case of cube, we start with square. In case of square, we start with power 1. So in case of power 4, the second factor should start with power 3. Generalize. Correct? And then again you will find the same pattern. In this case, you don't have any coefficients. Like in expansion we had no coefficients. In this case we don't have any coefficients, but the power of a and b are following the same pattern as expansion. Power of a keeps reducing and power of b keeps increasing. So without wasting time, if I write a to the power 4 minus b to the power 4, I know all of you are following, all of you are understanding. It's quite simple. If it is a cube, the second should be a square b, reduce power of a, increase power of b. Reduce power of a, increase power of b. Reduce power of a, increase power of b. That is a to the power 4 minus b to the power 4. One of the factor has to be a minus b, and then second factor is this. We can further factorize this, but hold on, I'll tell you. First understand this part. Are you okay with it? So can you pause this video and try writing the factorization for a to the power 5 minus b to the power 5? Yes? Very good. You all got the correct answer. It's a minus b first factor, and second factor will start with a to the power 4. Keep reducing the power of a, keep increasing the power of b, reducing the power of a, increasing the power of b, reducing the power of a, increasing the power of b, reducing the power of a, increasing the power of b. Yes? Excellent. Very good. Brilliant. Good. So I will talk about the generalized part, but before that, let's talk about the factorization of plus, the positive ones. Now in case of positive ones, no, for a square plus b square you don't have any factorization. No, you don't. For a cube plus b cube, yes, for a cube plus b cube you have. What is that? A plus b, right? A plus b as one of the factor, and then you got a square minus ab plus b square. This is quite strange. When you got plus sign here, the second factor sign plus minus are alternate. Okay, don't get confused. In case of negative, the first factor is a minus b, and the second factor all the sign are positive. All sign for each term will be having positive sign. Okay, second factor all positive sign. Whereas if you talk about the positive a cube minus b cube, first is a plus b, and second one following the power of ab, same pattern, but the sign is plus minus alternate in case of positive, right? When you have a to the power 4 plus b to the power 4, you know what? No factorization. But when you talk about a to the power 5 plus b to the power 5, yes, it has got factorization again. It got factorization again. A plus b into a to the power 4, yes. The power of the second bracket is 1 less than the power of a and b. Power of second factor square is 1 less than the power of a and b. Power of second factor a to the power 4 is 1 less than a to the power 5. Power is 1 less, right? And then plus minus alternate, reduce the power of a, increase the power of b. Plus minus alternate, plus a square, increase b square. Minus, decrease a, 1, increase b cube, plus b to the power 4. Yes? Are you able to understand this? Yeah? So no factorization formula for a square plus b square, no factorization formula for a to the power 4 plus b to the power 4. Here we understand that this a to the power n plus b to the power n has factorization only for, note this has factorization only for n is odd. Only for what? When n is what? Odd. The power is odd. For even powers, In case of plus, no factorization. Yeah. Now let me take the reference of this. If I take the reference of this, you can see here a cube plus b cube. Okay, you are going to get a some brilliant outcome of this. So please stay tuned. Do not skip. So a to the power 4 minus b to the power 4. If I further look at this, so I can see here a to the power 3 and b to the power 3. If I take this together, I can further factorize this a cube plus b cube, and I will have a square plus a square b plus ab square. Here, if I write this like, rearrange and write it like this. Okay, please try understanding. If not, don't worry, learn the final outcome. That is also fine. Here, I am going to tell you the final outcome. Don't worry. So this further I have a minus b, and this a cube plus b cube here, a cube plus b cube will have first term as a plus b and the second term as a square minus ab plus b square. Okay, and from here, let me write it like a plus b, stay tuned, a square minus, don't skip. I know it might be confusing because you're doing it first time, but don't skip. Okay, so this first term I factorize like this. Yeah, this is the first term I factorize, a cube plus b cube, applying that formula. Now in the second term, which is a square b plus ab square, I can see a and b are common in both. So if I take this common, I have a plus b again. This is the second term. Look at this carefully. First term what I did and second term what I did. Yeah. Now if you take these two terms, the first term and the second term, yeah, marked with, underlined with blue. I can take a plus b from here and a plus b from here, and I can take out of I can take these terms as this factor out of the bracket. So it will look like a minus b was already there. You got a plus b, and then remaining is what? A square minus ab plus b cube, b square, not b cube, b square. And plus I got a plus b. I know there is another way also to simplify this, but I wanted to show you this also. So you got a minus b, a plus b, and then here you got a square plus b square, which cannot be further factorized. Yeah, a square plus b square is remaining, right? That is what happened when you're trying to factorize a to the power 4 minus b to the power 4. So this factorization, I am sure it is clear to you. A minus b, a cube plus a square b plus ab square plus b cube. This is fine with you, right? And then when you can also look at this way also, but here I'm just trying to prove here that when it is a to the power 4 minus b to the power 4, one of the factors is a minus b and the second factor is a plus b. Yeah. Now let me talk about the generalization. So I hope this a square minus b square is clear, a cube minus b cube is clear, a to the power 4 minus b to the power 4 is clear, right? Now a to the power 4 minus b to the power 4, if I further factorize the second factor, I also get a plus b as one factor, right? Now let me write some generalizations for you here. Some general properties which we can understand, some general characteristics here which we can understand. So for a to the power n minus b to the power n, first is one of the factor, what is factor? The bracket which we have common, factor. Yeah, factor which is also called divisor. Yeah, like for example here we said 2 and 3 are factors of 6, 2 into 3, that's how we can factorize. That means 6 can be easily divisible by 2 or 3, right? So one of the factor here is a minus b. Always, you can see always you have a minus b, a minus b, a minus b, a minus b, right? So a minus b is one of the factor, always, right? What more we can say? We can also say if n is even, then you will for sure you will always have a minus b as one of the factor and a plus b also as another factor. Yeah, write this down, this is very important. If n is even, then a minus b is a minus b and a plus b, you will get these two as factors of a to the power n minus b to the power n. Okay, if n is even, then you will get a minus b and a plus b as factors for sure. What is the remaining, the other bracket, you don't need to worry, but these two factors you will definitely get. All right. Okay, so these two properties are important. Apart from that, when you say a minus b is one of the factor, the other factor, all the terms are positive. Now those things we are not going to, that's not going to be of much of use. That will be only to write the second factor, that a square plus ab plus b square. So all the terms are positive in the second factor, that's fine. But these two properties will be utilized in near future when we solve number theorems. Okay, number property. Here in case of a to the power n plus b to the power n, that can be factorized only when, as factorization only when n is odd. What else can we say? Second, this is the first condition. The second property, I can say property here that a to the power n plus b to the power n always will have, okay, always will have as one of the factors as a plus b. Okay, one of the factor as a plus b, remember this. Yeah, just to understand these two property we did all this panchayat. Yeah, okay, so let's conclude. I hope you understood the factorization part. If not, please revise this part of video. I've made it quite easy for you. I tried explaining you, if it is a to the power 4 minus b to the power 4, you can further factorize the second factor. Okay, you don't have to really follow this part, but the conclusion is important. Conclusion is, if n is even, you will have a minus b as one of the factors, and the second factor will be a plus b. So one of the factors is a minus b here, and if n is even, then you will also get a plus b as one of the factor. Okay, here in case of a to the power n plus b to the power n, that can be factorized only when n is odd, and if that's the case, a plus b will always be one of the factors, right? So this is it in today's video. I hope you watched completely without skipping any part. I will see you in the next lecture. Till then, keep learning and stay healthy and stay happy. Bye bye.